If I'll ask you what a soil is, then what you will answer most probably? You will answer it is a three-dimensional structure, it consists of soil physics, chemistry, biology, it consists of soil particles, it has different structure, it has bulk density, it has particle density, it has porosity. But if I'll ask a farmer what does the soil means, he will simply answer the soil on which we grow crops. So from different entrepreneurs, different people, we can expect different answers, right? If we ask a civil engineer, what he will answer? He will answer that yes, soil is, we make different construction on it, right? As we are agriculturists, we might find soil very interesting because soil, if we generally talk, that is a part of lithosphere, right? But if we think deeply, then soil has infinite source of life. Soil itself means source of infinite life. If we break soil, S-O-I-L, that is source of infinite life. Different microbes present in soil, and soil is obviously the best material for any crop growth, starting from germination to its, it provides nutrient, water to plants. It gives anchorage, it gives support to plant. So students, welcome back to my channel, and in this particular session we will have a great discussion on introductory soil, and this will be a marathon session. So this is not basically an introductory part, this is basically for them who have completed their soil science course in graduation and preparing for JRF in physical science, right? And who have completed their masters and preparing for SRF exam and NET exam in natural sciences, right? And whoever are preparing for ARS exam and other competitive examination, this course is for them only. This marathon course will be for them. So in this course we'll talk about introductory soil science, how soil forms, how earth forms, what are the different perspectives of soil science like soil pedology, soil edaphology, soil physics, soil chemistry, soil biology, humus, organic matter content of soil, how they develop, right? All these things we will cover in this marathon session. So I request you all to just go through each point, bit by bit, and try to understand all these points. If you want to take notes, you can pause the video and you can take the notes also. I have tried to cover every aspects of soil science in this 1 hour 15 minutes video. If you want to switch to any particular topic, then the timestamp is here. You can go and start from a particular moment, right? And if you have any doubts regarding soil science or agronomy, more than 250 videos I have already uploaded in my channel. And if you find any video interesting, then just watch it. If it is relevant to your preparation, if it is coinciding with your syllabus, then just watch it. For more lectures, for more updates, you can just subscribe to my channel, and you can join our Telegram group, that is Agriculture Q&A. So you can join there. We are organizing different quizzes there, and we are giving updates about different lectures there. So let's start the topic, marathon to soil science. Watch the video and let me know how you feel it. If you like the video, then give a thumbs up.
What is soil pedology? Soil pedology. What is soil pedology? Soil pedology is the formation, chemistry, morphology, and classification of soil. That is Greek word from pedon. Pedology was derived from Greek word pedon, that means earth. Okay. What is soil pedology? Soil pedology is the formation, chemistry, morphology, and classification of soil. Right. Then what is edaphology? What is edaphology? This is the influence of soil on plants, that is known as edaphology. So what is the difference between pedology and edaphology? Pedology is mainly dealing with the formation, chemistry, morphology, and classification of soil, while edaphology is the influence of soil on plant growth, the study of influence of soil on plant growth, that is known as edaphology. Edaphology was derived from Greek word edaphos, that means soil or ground. So disciplines of soil science, there are different disciplines of soil science. They are soil fertility, soil chemistry, soil physics, soil microbiology, soil conservation, soil pedology. So we will cover one by one. Pedology is basically the genesis, survey, and classification of soil. What is soil? Soil, if we expand it, then source of infinite life. source from S, source, O of I, infinite, L, life. Soil is a source of infinite life because there are a lot of organisms, microflora, macrofauna. So they are residing in the soil. So soil is known as source of infinite life or soul of infinite life. And soil, the word soil is derived from Latin word solum, that means floor. Who is the father of soil science? Dokuchev, a Russian scientist. He is known as the father of soil science. So, origin of Earth's planet, how Earth's planet was originated. There are different hypotheses like nebular hypothesis by Kent and Laplace in 1755. Planetesimal hypothesis, it was given by Chamberlain and Moulton in 1905, and this is a biparental origin. Then gaseous tidal hypothesis, it is the most popular hypothesis, that was given by Jeans and Jeffries in 1925. Tectonic plate theory, then continental drift theory. These are some of the theories or hypotheses by different scientists on behalf of origin of Earth. So if we consider soil body as its body, so we can find around 50% solid and around 50% like pore space. So among the 50% pore space, we have 25% air, 25% water, and among 50% of the solid, we have 45% mineral matter and 5% organic matter. So this is the basic constituent of soil. The oldest material found on Earth is zircon. Zircon is the oldest and it is the toughest material, and it is most resistant material to weather, and it is found in Australia during 4.3 billion years ago. I mean, it is there from 4.3 billion years ago. So how we know a materials, it's like how many years it has. So we know that using different techniques like carbon dating, etc. So geological development of life. So how life evolved, what are the evolution strategy? First was Archean. Archean means lifeless. Initial stage of Earth, that is Archean stage, that is lifeless. Then Precambrian. There we find soft-bodied plants and animals. Then we have Paleozoic. There are mammals, reptiles, dinosaurs, plants and animals. They are, from Precambrian to Paleozoic, right? And between Precambrian to Paleozoic, there are different, like Cambrian where algae evolved, then Ordovician where molluscs and seaweed evolved, then Silurian where land plants evolved, then Devonian where Java fish evolved and amphibians evolved, then Carboniferous there, non-fungus plant like, then Permian where reptiles evolved. Then we have Paleozoic. From Paleozoic there is Mesozoic where we have like Triassic period, Jurassic period, Crustacean period. In Triassic period, marine and reptile mammals and reptiles evolved. Then in Jurassic period, dinosaurs evolved. Then plants and fishes evolved in Cretaceous period. Then Cenozoic. From Mesozoic, it is Cenozoic. Then in Cenozoic, there are different time period where Eocene, where mammals and terrestrial plants, terrestrial animals evolved. Then Miocene, Pliocene, then Pleistocene, then recent, that is mammals evolved, right? So these are certain evolutionary mechanism of our Earth. Then if we see our Earth, there is outer crust. The outer layer is known as crust. The middle layer, that is known as mantle. Then the inner layer, that is known as core. If we see from outer layer, in outer layer we are residing on the outer layer, right? Covering us, we have our atmosphere. Then if we go deeper and deeper, first layer is crust, that is from 5 to 56 kilometer density, and density is 2.6 to 3 gram per cc. And it is 5 to 11 kilometer deep. Then mantle, from that layer, from crust layer, if we go beyond, then we find mantle, that is 2900 kilometer thick, and here the density is 3 to 4.5 gram per cc. And major minerals we found mixed or silicate mineral mostly found. Then in core we have 3500 kilometer thick. The density is highest, like 9 to 12 gram per cc, and here the major component is nickel and iron, right? So In crust also we have two layers like Cial and Sima. Cial is heterogeneous mixture and Sima is homogeneous mixture. Sima, that is Cial floats on the Sima, right? Cial floats on the Sima, means Cial is the outer layer and Sima is the inner layer. So this is if we go from surface to deeper layer, this is the strata, crust, mantle and core. Then composition of atmospheric air and soil. Okay, first composition of atmospheric air we will discuss. So by volume basis, if we see composition of atmospheric air, that is nitrogen 78.08%, by weight basis it is 76.5%. If we see oxygen, that is 20.9% by volume basis, 23.1% by weight basis. If we see carbon dioxide, that is 0.03%, now it is 0.04%. If we other gases, they are 0.93%, and measure is from other gases measure we can find that argon, right? Then mineral elements, they are classified according to yes. So first we will see the composition of earth crust. If we see composition of earth crust, then highest is oxygen and silicon. Oxygen we can find in earth crust like 46 to 47%, silica 27.72%, aluminum 8.13%, iron 5%, calcium around 3.63%, sodium is around 2.83%, potassium around 2.59%, magnesium around 2.09%, and other 1.41%. So mostly we found oxygen and silicon in earth crust, that is around 3/4 of the total constituent of earth crust. Then mineral element, they are classified according to their bonding with other constituent, like lithophile element. Which minerals we call lithophile elements? Those form stable oxyanion. They bind with oxygen and they form stability after binding with oxygen. So they are the examples are oxygen, silicon, titanium, iron, manganese, lithium, sodium, carbon, etc. Then chalcophile elements. This forms covalent bond with sulfide. Chalcophile elements, they form covalent bond with sulfide, like sulfur, selenium, tellurium, nickel, lead, argent, means gold, silver, etc. Then siderophile element, they forms metallic bonds. Siderophile elements forms metallic bond, like iron, nickel, copper, rhodium, palladium, aurum, like gold. Then atomophile element, they remain as atmospheric gases, like nitrogen, oxygen, helium, nickel, krypton, xenon, etc. Then biophile element, they associate with living organism, like carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, calcium, magnesium, zinc, cobalt, etc. Then let's discuss about rocks and minerals. So earth crust is like composition, from rock the soil evolved. Rocks and minerals, the soil evolved. Soil is basically the weathering part of the rock, right? So petrology, what is petrology? It is the study and description of rock. Study and description of rock is known as petrology. Rocks generally forms from molten magma. Then rocks again are divided into primary rock, metamorphic rock, primary rock or igneous rock, then sedimentary rock or secondary rock, and then metamorphic rock. Rocks are of three types. One is primary or igneous rock, one is secondary or sedimentary rock, another is metamorphic rock. Primary igneous rock means the rock forms from molten magma. Sedimentary or secondary rock, that is transportation and concentration of primary rocks. Then metamorphic rock, alteration of primary and secondary mineral, that is known as metamorphic rock. So the broad classification here, it is rocks. Rock is basically igneous, sedimentary and metamorphic rock. So igneous rock again divided into intrusive rock and extrusive rock. Intrusive rock means the igneous, the lava, it solidifies inside that inside earth crust. Then extrusive means it comes out and solidifies. So intrusive rock example, gabbro and granite, that is also known as volcanic. Then extrusive rock example, basalt and rhyolite, that is also known as plutonic rock. So based on silica content in this igneous rock, they are again classified into acid igneous, basic igneous. So acid igneous means there is more than 65% silica in that rock. So example are granite and rhyolite. Then basic rocks means less than 40 to 55% silica. So if we find higher silica than 65%, then that is acidic. Then if we find lower silica like less than 40 to 45%, then that is known as basic rock. So basic rock, example gabbro, basalt. Then sedimentary rock, this is about igneous rock. Then sedimentary rock, they are clastic and chemical. Clastic means sandstone, shale, these are clastic rock. Then chemical like limestone. Then metamorphic rock. These examples are very much important from exam point of view, right? Examples, you should remember these examples. What are the igneous rock, what are the sedimentary rock, what are the metamorphic rock. Then metamorphic rock again divided into foliated, non-foliated rock. So example of foliated rock are slate, schist. Example of non-foliated rock like quartzite, marble. These are example of non-foliated rock. So other examples like igneous rock, if we see granite, syenite, diorite, gabbro, basalt, these are igneous rocks. Sedimentary rocks like based on origin like residual rock like laterite, transported rock like solid suspension like sandstone, shale, chemical precipitation like limestone, agency of organic matter like peat. Then based on grain size, if we see sedimentary rocks are again classified as pebble sized like conglomerate, sand size like sandstone, conglomerate, silt size like siltstone, clay sized like shale, midstone like fuller's earth. These are some of the based on grain size sedimentary rocks are classified like this. Then metamorphic rock. Metamorphic rock due to water, that is called hydrometamorphosis. Due to pressure, that is known as dynamo metamorphosis. Then sandstone. So some sedimentary rocks, they are transformed to metamorphic rock. So what are their like sandstone transformed into quartzite, shale transformed to slate, schist limestone, and limestone transferred to marble, granite transferred to gneiss. Okay, so minerals. Then comes to rocks, we discussed different types of rock. Then minerals, solid substance composed of atoms having orderly and regular arrangement, that is known as mineral. So minerals are the fundamental building blocks like silica tetrahedron, this is mineral, silica tetrahedron and aluminum octahedron. So silica, if we see there are different types of minerals, so there are different types of classification also. So silica and non-silicate, silicate and non-silicate minerals. Silicate minerals examples are orthosilicate, inosilicate, phyllosilicate, tectosilicate. These are silicate minerals. Non-silicate minerals means oxides, carbonates, sulfonate, phosphate. These are non-silicate minerals. Then some are primary minerals, some are secondary minerals. Primary minerals examples are feldspar, mica, etc. Original components of rock. Primary minerals are original components of rock. Whereas secondary minerals formed from change of primary mineral due to different agencies. Primary minerals changes to form secondary minerals. These are mainly clay minerals. Secondary minerals are generally clay minerals. Then primary minerals again classified as ferromagnesian, non-ferromagnesian. So examples of ferromagnesian are orthosilicate, phyllosilicate. Examples of non-ferromagnesian, these are tectosilicates. Then again minerals are classified into essential minerals, accessory minerals. So what are the essential minerals like feldspar, pyroxene, mica? These are the chief constituent of rock. Like feldspar, pyroxene, mica, as you know, these are the chief constituent of rocks. Then accessory minerals, these are their presence or absence do not alter the properties of rock. So examples are tourmaline, magnetite, etc. These are present in small quantity. Accessory minerals, these are present in small quantity. Then mica. Mica are again classified imperfectly ordered, well ordered. Imperfectly ordered contains less potassium and more water. Perfectly well ordered, that is derived from sedimentary rocks like muscovite, pyrolusite, biotite, phlogopite. Then ferromagnesian mineral, these are examples are pyroxene, amphibole, mica. Non-ferromagnesian mineral like feldspar, quartz, silicate minerals, non-silicate minerals. So what are the feldspar? Feldspar means potassium feldspar. Then plagioclase feldspar. So examples of potassium feldspar are orthoclase, that the formula is KAlSi3O8, microcline, then adulorite. Okay, then plagioclase feldspar like albite, that is sodium aluminum silicate, anorthite, calcium aluminum silicate. Then quartz, these are highly packed, high degree of purity, high resistance to weathering, quartz. Silicate minerals like orthosilicate, neosilicate, inosilicate, phyllosilicate, tectosilicate. Non-silicate minerals like oxides, such as hematite Fe2O3, limonite Fe2O3.3H2O, geothite, that is FeOH-H2O, gypsite Al2O3.H2O. Then carbonates like calcite CaCO3, dolomite CmgCO3 then sulfate, gypsum CaSO4.2H2O, phosphate like apatite Ca3PO4 So you have to remember the example of different minerals, and again you have to remember the chemical constituent because they are also important from exam point of view. Then physical properties, what physical properties does mineral have? Like they have different colors, they have different streaks in unglazed porcelain, like hematite red streak, magnetite black streak, talc white streak. Then they have different taste, like halite they taste salty. Then they have different specific gravity, they have different magnetism property, they have different effervescence properties. Then birefrange or double refraction properties, then fluorescence properties some minerals have. Then fracture and cleavage also they have, some have like different types of fractures. If we beat them, if we try to break them, they have different types of fractural properties. Then hardness, it is measured in Mohs scale, and that the scale ranges from 0 to 10, where talc the hardness is 1 and diamond the hardness is 10. So diamond is the toughest and talc is the weakest mineral. Then some have different lusters. Minerals have different lusters like metallic, submetallic, vitreous, different types of lusters are found. Then crystal form like isometric, tetragonal, hexagonal, this type of different crystal form is found in minerals. Then secondary minerals again classified into silicate and non-silicate mineral, we have already covered. So a clay mineral, if we see and their classification, clay mineral and their classification, let's discuss. So some are silicate minerals, some are non-silicate mineral. Silicate minerals again classified according to their silica and aluminum ratio. So 1:1 non-expanding type, that is the example is kaolinite. 2:1 non-expanding type, here example are biotite, that is black mica. Then illite. Then 2:1 expanding type, some are expanding like vermiculite, some are fully expanding, those are montmorillonite. Then 2:2 mineral, that is chlorite. So these examples are very much important. So suppose in exam questions may be asked like which among the following is 1:1 clay mineral, which among the following is 2:1:1, or which among the following is 2:1 mineral. So you have to remember these examples. Then non-silicate minerals, these are hematite Fe2O3, limonite Fe2O3.3H2O, geothite FeOH-NH2O, gypsite Al2O3.2H2O, calcite CaCO3, dolomite CmgCO3, siderite FeCO3, gypsum CaSO4.2H2O, apatite or rock phosphate. Apatite is the major constituent of rock phosphate. Then weathering. What is weathering? Weathering is the loosening of like formation of soil, maybe you can say formation of soil from rocks and minerals, that is known as weathering. Weathering is the loosening of rocks. Like rock is hard, if we just think of a rock, what comes to our mind? That is a hard or that is a massive structure. So weathering is the loosening of that massive structure and formation of like primary and secondary minerals and soil. So that is weathering. Rocks forms regolith. Regolith is the unconsolidated parent material, and then then solemn develop, right? So physical and mechanical, there are different forms of weathering, that is physical mechanical weathering, that is called disintegration, chemical weathering, that is called decomposition, biological weathering, where decomposition and disintegration and decomposition like acts. So physical or mechanical weathering, that is called disintegration, that is depends on condition of rock, temperature, water, wind, atmosphere and electric. Then chemical and decomposition depends on hydration, hydrolysis, solution, carbonation, oxidation, reduction. Biological, that is a combination of disintegration and decomposition, depends on man, animal, plant, microorganisms. So soil formation factors and process. What are the factors affecting soil formation and how soil formation occurs? So rocks or parent material, they disintegrate or decompose to form regolith. Regolith, again soil forming, different soil forming factors affect on regolith. then forms true soil or solum. So Dokuchev in 1889 he proposed that soil formation is the function of parent material, climate, and organism. And Jena in 1941 proposed that soil formation is the function of climate, organism, then relief, plant, and time. Right. So from this climate and organism, they are called active factor, and like parent material, time, these are called passive factor according to Jena. So parent material is a consolidated rock. So this is again classified into sedentary rock and transported rock. So sedentary rock formed in original place, that is called rocks. Then transported rocks, they are named according to their transporting agency. Like if the rock is transported using like gravity, that is called colluvial. If it is transported by water, then that is called alluvial. Moraine, lacustrine, if it is transported by ice, then it is called glacial, or moraine if it is transported through wind, then it is called aeolian or loess. Then soil are again classified into endodynamomorphic soil, ectodynamomorphic soil. If the property of soil determined by parent material, that is called endodynamomorphic soil. If the soil properties are the inherited property from the parent material, then that is called endodynamomorphic soil. If the properties of soil dominated by climate and vegetation of that location, then that is called ectodynamomorphic soil. So granite is a acid igneous rock, whereas basalt is basic igneous rock. Often this question is asked in different exam. So topography according to FAO 1990, flat to almost flat if the topography is 0 to 2%, gently undulated if it is 2 to 5%, undulating topography if it is 5 to 10%, rolling topography if it is 10 to 15%, hilly topography if it is 15 to 30%, steepy or steepy dissect, that is more than 30% elevation, then mountains if it is more than 30% and elevation is also more than 300 meter. These are some of the factors like topography, this is some of the factor. Then time, if the time that nature devotes to soil formation, that is called pedogenic time. What is the time nature giving to form the soil, that is known as pedogenic time. Mature soil is having fully developed soil profile or horizon, which soil we call mature soil, that is formed over the time, right? Then weathering stages, there are different stages of weathering. So weathering, what are the stages? Like initial stage, juvenile stage, virile stage, senile stage, final stage. Remember this phase, okay? Initial, juvenile, virile, senile, and final. These are the stages of weathering. Jena in 1941 proposed that weathering of soil in tropic region 3 times faster than temperate region and 9 times faster than Arctic region. Arctic region means cold regions. Movement of solute through the water, infiltrated water or percolated water, that is known as leaching. Movement of suspension, it is called alluviation. There are different fundamental soil forming process. These are some of the fundamental soil forming process, like humification. This is the transformation of raw organic matter into humus. Then alluviation, that is the washing out of or movement of certain constituent in suspension within soil profile. That is also called E horizon. Then illuviation means process of deposition of soil material, that is alluviated, that is in B horizon, right? Then horizonation, formation of soil horizon due to humification, alluviation, and illuviation, right? So this is known as horizonation. These are fundamental soil forming process. Then some of specific soil forming processes like calcium calcification, decalcification, porzolization, lacteration, glaciation. These are some of the specific soil forming process. What are the specific soil forming processes? Like calcification, decalcification, porzolization, lacteration, glaciation, salinization, desalinization, solidization or dealkalization, peroturbation. These are some of the specific soil forming processes. Like what is calcification? Calcification is the accumulation of calcite. Then decalcification, that is the process of removal of calcite by leaching. Porzolization is the leaching of sodium of calcium carbonate and sesquioxide and humus. So due to porzolization, ash-like horizon developed. It is prevalent in cold and humid climate where conifers and acid forming vegetation are predominant. Lateration, that is removal of silica and deposition of iron and aluminum oxide, right? This layer is hard and brick-like structure developed due to lateration. Formation of lateritic soil developed. This is most prevalent in warm and humid climate where more temperature and basic parent material rich in ferro-magnesium mineral. Then glaciation. Glaciation is the clay or green clay developed in lower horizon due to waterlogging. Here we can find poor aeration and called hydromorphic soil. Glaciation is also a glaciation where the soil where glaciation found, that is known as hydromorphic soil. Here iron Fe3 plus is reduced to Fe2 plus, required both organic matter and microorganisms. Salinization, this is the process of accumulation of salt like sulfate, chloride, calcium, magnesium, sodium and potassium. Desalinization, that is the removal or leaching of excess soluble salts from horizon. Solonization or alkalization, that is accumulation of sodium ion to sodic soil, that is solenoids. Solidization or dealkalization. Solonization is the alkalization process. Solidization is the dealkalization process. Here the process of exchange of calcium magnesium with sodium on exchange complex and leaching or removal of sodium from clay complex. Dispersion occurs due to sodium because sodium it causes deflocculation, right? Sodium, it is a hydrophilic molecule, so it attract the water present in the clay mineral and it disperses the clay mineral and it degrades the soil structure. So sodium is causing dispersion. What is peroturbation? Peroturbation is the faunal peroturbation. There are different types of peroturbation: faunal peroturbation, floral peroturbation, argillic peroturbation. Peroturbation is mixing of soil. Okay, so faunal peroturbation means by animals like earthworm, mole, rodent, man, etc. That is called faunal peroturbation. Floral peroturbation, that is by plant. Argillic peroturbation, that is by mixing by churning process, by swell, shrink, as in black cotton soil. If we find, that is argillic peroturbation. Then soil profile. If we dig a soil, if we go see the soil profile, then there are mainly like A, B and C like horizons. A is the alluvial horizon, B is the alluvial horizon, C is the parent material. So if we see, there are five kind of profiles, layers. So first one is rock layer, that is the beneath layer, rock, that is consolidated mass. Then C is the parent material above the rock, that is parent material. Then A and B horizon, that is known as soil. Okay, and regolith, A plus B plus C, that is called regolith. So O is the organic horizon where more than 20 to 30% organic matter found. Then A is the mineral horizon, uppermost mineral horizon is known as A horizon. Then B is the darker alluvial zone or red color. Okay, so pedon. What is pedon? That is the smallest volume that can called soil. Pedon is the smallest volume that can be called as soil. What is polypedon? That is similar to pedon, similar pedons bounded and minimum area of 1 square kilometer and unspecified maximum area. So polypedon should be like should consist of similar pedons and it should be minimum of 1 square kilometer area. Then soil physical properties. What are the soil physical properties? Like texture, structure, surface area, density, porosity, color, consistency. These are soil physical properties. What is texture? Soil texture, that is the relative proportion of soil separates. Like what are the soil separates? Sand, silt and clay. So their relative proportion is called soil texture. Then which are known as soil separate? What are the characteristics of soil separate? They are having more than 2 mm diameter. Less than 2 mm diameter. The particles which are having more than 2 mm diameter, they are not considered as soil separates. So according to USDA, soil texture are classified as like clay if the particle size, the diameter of the particle is less than 0.002 mm. Sealed if the diameter of the particle is 0.05 to 0.002 mm. Then very fine sand 0.05 to 0.1 mm, fine sand 0.1 to 0.25 mm, coarse sand that is 0.5 to 1 mm, very coarse sand 1 to 2 mm. According to ISSS, that is the International Society of Soil Science, clay if the particle size is less than 0.002 mm, silt if 0.02 to 0.002 mm, fine sand if it is 0.02 to 0.2 mm, coarse sand that is 0.2 to 2 mm. And another BSI classification and European system, if you can see, then you can just go through that. Then if the particles are not considered soil separates, then they are classified as the larger particles. They are classified as gravel if it is 2 to 4 mm diameter, then pebble if it is 4 to 65 mm diameter, cobble if it is 64 to 256 mm diameter, boulder if it is more than 256 mm diameter. Then sand and silt, these are the skeleton of soil. Sand and silt constitute the skeleton of soil. Clay constitute the flesh of soil, right? So as in our body, the bone and muscles are there, and there is blood also. So like that, in soil, sand and silt, they forms the skeleton of the soil, and clay, it forms the flesh of the soil. Then particle size distribution on determination, it is done by two-step process, like complete dispersion, and another is amount of each group, like complete dispersion. For removal of iron and aluminum oxide, HCl is used. For organic matter, H2O2 is used. Then for soluble salt, precipitation technique is used. Then surface tension, stirring with H2O, boiling H2O. Then the soil is dispersed using NaOH, sodium hydroxide. So the removal of coarse fraction by sieving and finer fraction classification by studying the proportion of finer fraction, that is by using Stokes law and using Voyko's hydrometer. So what is Stokes law? Stokes law is given by Stokes in 1851. According to this law, the terminal velocity is directly proportional to the square of the radius of the particle, right? So Stokes law is V is equal to 2gr square rho s minus rho l divided by eta. Eta is the viscosity, that the unit is poise. So methods of textural determination. There are different methods like elutriation method, pipette method, then decantation or beaker method, test tube seeking method, field method. So these are certain methods of using of determining soil texture. So when we called a soil a sandy soil, if it contains more than 80% sand and less than 15% clay, then that is known as sandy soil. When it is called silty soil, if it is more than 80% silt and less than 12% clay, that is known as silty soil. And when it is called clay soil, if that is greater than 40% of clay fraction, then it is known as clay soil. Textural determination is done by, after the analysis of soil separates, how many percentage of sand, silt and clay in soil by using Stokes law. We use the textural triangle developed by USDA to determine the soil texture, right? Then soil structure. This was all about soil texture. Then soil structure. What is soil structure? Soil structure is the arrangement of primary and secondary soil particles. What are the primary soil and secondary soil particles? And their arrangement into a different form, into a particular form, that is known as soil structure. In a particular form, how primary and secondary soil particles are arranged, that is called soil structure. That is, soil structure mostly affect the soil water, soil air, root growth, germination percentage, microorganism activity. These are affected by soil structure. Then what are soil particles? Soil particles like single grain particle, massive particles, then they are combined with each other. What are the factors? They affect the combination of these soil particles like organic matter, iron and aluminum oxide, colloidal clay. These form cementation with these primary and secondary particle or single grain and massive particles to form secondary particles, right? These secondary particles and these secondary structures are known as soil structure. So if the soil is having colloidal clay, then there is more surface area and the reactive fraction is more. So clay soil are more reactive than sandy soil. Why? Because of having larger surface area in clay soil. So flocculation is the first step of aggregation. How soil aggregates, how they close apart each other due to flocculation. Flocculation, what are the flocculating agency? Like calcium, magnesium and aluminum, they are the main flocculating agent, maybe they are the main flocculating mineral which form aggregation. And aggregation also depends on hydration, dehydration, pressure. What are the hydration, what are the water status, what if that is hydrated or dehydrated, or how the pressure is there. So all these factors, they affect the flocculation of the soil. There are three types of three category of soil structure. One is type, class and grade. Type, class and grade. Type represent the shape or form of arrangement of pattern or bed. Class represent the size of bed. Grade represent the degree of distinctness of bed. Type represents the shape or form of arrangement pattern of bed. Class represents the size of bed. Grade represents the degree of distinctness of bed. So aggregates are maybe natural aggregate or artificial aggregate. Natural aggregates are known as bed. Artificial aggregate are known as clod. So types, there are different types of soil structure, like plate-like or platy soil, prism-like, block-like, spheroidal. Plate-like or platy soil, again thin, that is called laminar. Thick, that is called platy. Prism-like, again classified into columnar and prismatic. Columnar means round top, prismatic means flat top. Block-like, again classified into angular blocky, subangular blocky. Spheroidal, again classified into granular and rhombic. Granular means less porous and rhombic means porous. So this is the type of soil structure. Then class of soil structure, there are very fine or very thin, then fine or thin, medium, coarse or thick, very coarse or very thick. These are the class. Class means size of beds. Then grades of soil structure: structureless, weak structure, moderate structure, strong structure. These are grades of soil structure. So there are three categories of soil structure. Then factors affecting soil structure. What are the factors affecting soil structure? Like climate, organic matter, tillage, plant root and residues, animals, microbes, fertilizer, wetting and drying, exchange of cations, etc. Inorganic cements, clay, water, etc. So these are the factors affecting soil structure. Effect of soil structure on physical properties. How soil structure affects physical properties? Like it affects porosity, it affects soil temperature, it affects soil consistency, it affects soil color. Then soil aggregates. Well aggregate soils are more stable and less susceptible to erosion. Why soil aggregate is important? Because well aggregation, if soil is well aggregated, then it is more stable, it is less susceptible to erosion. Then bacteria, fungi and actinomyces, like bacteria, what are the bacteria? So these are the microbes. Microbes actually, they secrete some like glomalin or maybe some substances which actually make the soil aggregate, which actually make the soil aggregation more stronger, right? So bacteria, they secrete some polysaccharide, then some electrostatic charges like that helps in aggregation. Fungi, they form hypha, they form VAM, which secrete glomalin, right? So glomalin is first discovered by Stara F. Waite from USDA. It is a glycoprotein which forms soil aggregation, right? Soil aggregation improves soil infiltration or percolation, decrease crusting, increase resistance to rain or splash, reduce runoff, right? If soil aggregation is more, then there is reduction of soil erosion, reduction of soil runoff, there is more infiltration, there is reduction of crusting problem, etc. And soil consistence. What is soil consistence? Resistance of soil at various moisture content to mechanical stress or manipulation, that is known as soil consistence. Both cohesive and adhesive force act on soil consistency. Cohesive force means that is the attraction of similar kind of particles. Suppose water molecule, soil molecule, that is cohesive force. If different molecules attract each other, then that is called as adhesion force. 3 moisture level, that is wet, moist and dry. Wet means stickiness and plasticity is there. Stickiness stickiness again classified as non-sticky, slight sticky, sticky, very sticky. Then plasticity, if the soil having more than 15% clay, then the soil is said to be plasticity, develop plasticity. Then they are classified again into non-plastic, slightly plastic, plastic, very plastic. Then moist, that is loose, very friable, firm, very firm, excessive firm. Dry, that is loose, soft, straight, hard, slightly hard, very hard, extremely hard. These are different soil consistency level. And particle density or true density. Particle density is also known as true density. The value is from 2.65 gram per cc. That is, if particle density is higher, then the mineral is having higher mass, means the mineral is heavy, like magnetite, limonite, hematite constituent. If particle density is higher, there is particle density is higher when organic matter is lower. If organic matter in the soil is higher, then the particle density is lower. So the formula of particle density is mass of soil mass of soil divided by volume of soil solid, right? That is particle density. What is the bulk density? Bulk density is also known as apparent density. What is bulk density? That is mass of soil divided by volume of soil including pore space. In particle density, that is excluding pore space, only the soil solid volume is taken. But in bulk density, that is called apparent density, where there is in mass of soil divided by volume of soil including pore space, that is in bulk density, right? So bulk density, the value in sandy soil is 1.6 gram per cc. Then in if organic matter is high, then 0.5 gram per cc. If there is clay, 1.1 gram per cc. So generally soil having low bulk density have favorable physical condition. Generally soil having, this is not true for everywhere. Generally soil having low BD have favorable physical condition. Factors affecting bulk density, that is pore space, texture, organic matter content. These are the factors affecting bulk density. Then what is porosity? Porosity means from the soil, what is the portion of pores are there? What is the portion of pore space? Why pore space are needed? Because to conduct water, to conduct the temperature, to aerate the root, to aerate the soil living microorganisms. Aeration is most important. So if the soil is porous, then microbial growth, the soil ecology will be much more better. So porosity, pores are again classified, soil pores are again classified into macropore and micropore. Macropores are non-capillary pores. If the pore diameter is more than 0.06 mm diameter, then that is called macropore or non-capillary pore. If the soil pore diameter is less than 0.06 mm diameter, that is called micropore or capillary pores. Porosity can be calculated using BD and PD, bulk density and particle density. The formula is 1 minus bulk density by particle density into 100. So in sandy surface soil, if we see, there is 35 to 50% pore space, medium to fine texture soil 50 to 60% pore space, and compact subsoil, if we see, 25 to 30% pore space is there. Virgin soil have more porosity than cultivated one. Okay, virgin soil have more porosity than cultivated one. Soil compaction. What is soil compaction? That is the method of mechanically increase the density of soil. So increase in density means, what is density? Density is equal to mass by volume. Increase in density means volume is decreasing, so soil porosity is decreasing. So in soil compaction, what happens? Increase in density of the soil mechanically, right? So if we use heavy machinery in our field, then there is increase in load, there is decrease in porosity, right? There is increase in density, right? So we should avoid increase in heavy machinery on our farm. In soil color, this is all about like soil texture, structure and aggregation. Soil compaction. So soil color, how soil color is represented using Munsell color chart. So what are the factors affecting soil color? Organic matter, iron, silica, lime, salt, alternate wetting, drying, oxidation, reduction. This affects soil color. Soil color is represented by hue, value and chroma. Hue, what is hue? That is the dominant spectral color represented by GYRV. Then value is the lightness or darkness of the soil, that is amount of reflecting light. Then chroma is the purity or strength of the color. So suppose example, here is 2.5 YR 5/6. The 2.5 YR, that is called hue, and 5, that is called value. Chroma means 6, that is represent chroma, and this total band is representing red color, right? Then soil water is very much essential because water is uptaken by plants for its metabolic activity, and it is also important for the soil residing microbes and microflora, fauna, etc. So soil water is very much essential. Factors affecting soil water, that is texture, structure, organic matter, density, temperature, salt content, depth of soil, clay type, etc. Classification, physical classification, if we see, then gravitational water, capillary water, and hygroscopic water. Gravitational water present in less than 0.0 to 0.1 or 0.33 atmosphere pressure, or bar, minus 0 to minus 0.1 or minus 0.33 bar, that is gravitational water. Capillary water, the water potential is 0.33 to 31 atmosphere or minus 0.33 to minus 31 bar. Hygroscopic water, if the water potential is more than minus 31 bar, that is called hygroscopic water. This is physical classification. Again, biological classification, there is available water, there is unavailable water, and there is superfluous available water. So available water is between field capacity to permanent wilting point, that is minus 0.33 bar to minus 15 bar. Unavailable water, that is 0 to minus 0.33 bar, and beyond minus 15 bar, that is unavailable water. Then how water retained in soil? So water retention depends on cohesion, adhesion, and surface tension, right? So what is surface tension? Mainly water and air interface, that is water and air interface, there is surface tension. So if we see water molecule is dipole nature due to oxygen negative charge in oxygen and hydrogen positive charge in hydrogen, and HOH, whatever bond angle we find, that is 104.5 degree. So there is energy in soil water that is due to metric forces, that is adsorption, osmotic forces, that is due to soil solution, salt solution, and gravitational force due to gravity. Gravitational force is positive, osmotic and metric force is a negative. So total water potential is equal to metric potential plus osmotic potential plus gravitational potential. And there are soil moisture constants, different soil moisture constants are there. So amount of water soil contains at particular suction or equilibrium point, those are like saturation in case of saturation, or maximum water holding capacity, that is the soil water potential is 0 bar. If we say field capacity, there is soil water potential is minus 0.1 bar to minus 0.33 bar. Permanent wilting point, there the soil water potential is minus 15 bar. Hygroscopic coefficient, there the soil water potential is minus 31 bar. Ultimate wilting point, there is the soil water potential is minus 60 bar. Moisture equivalent, what is moisture equivalent? That is the percentage of moisture held by 1 cm thick moist layer of soil subjected to a centrifugal force of 1000 times of gravity for 30 minutes. That is known as moisture equivalent. So these are the soil moisture constants. So maximum water holding capacity, that is 0 bar. Then at that moment, actually the micropond and macropore, they are filled with water. Then gravitational water, that is the water at potential 0 to minus 1/3 atmosphere or 1/3 bar, and PF is 2.54 there. So here the water actually percolate and goes beyond the root zone, right? It is not useful for plant, the gravitational water. Then there is sticky point where the water is at 2.54 PF and more than 1/3 atmosphere. Then field capacity, when the PF is 2.5 and water potential is 1/3 bar. Moisture equivalent, that is 1/3 or 1 atmosphere, PF is 2.723. Capillary water, that is 1/3 atmosphere to 31 bar or minus 1/3 bar to 31 bar, where PF is 2.54 to 4.5. Permanent wilting point, where PF is 4.2 and it is at minus 15 bar. Hygroscopic coefficient, the water potential is minus 31 bar and PF is 4.5, right? 4.5 to 7. So these were some of the energy status of soil moisture constants. Then water movement, how water moves inside the soil. There is saturated flow, there is unsaturated flow, there is water vapor movement. So saturated flow, when the water potential is less than minus 30 minus 0.33 bar, then that is saturated flow. That is called gravitational flow, or when the soil pores are saturated, then the saturated movement happens. Then unsaturated flow, when it is beyond 1/3 bar, right? There is unsaturation, and adhesion and cohesion acts there. Then water vapor movement, it is the internal movement due to DPD, diffusion pressure deficit, right? That's the vapor movement. Then methods of determination of soil moisture. How we can determine the soil moisture? There are direct determination and indirect determination. So in laboratory we can use gravimetric method, we can use electrical conductivity method or gypsum block method, we can use pressure plate and membrane apparatus. This is we can use in laboratory. Then in situ or field measurement, we can use tensiometer, we can use neutron moisture meter, we can use TDR or time domain reflectometry. This was all about how we can use different methods. So we can this is marathon session, so we are covering it in rapid pace. We will discuss all of these points later on in our particular chapter wise lectures, right? So soil temperature, movement of soil temperature, how soil temperature moves in different process like radiation, conduction and convection are there. So conduction is the particle to particle soil temperature movement. Convection is the temperature movement through particle by particle, that is convection. Then radiation, it is without any medium, the transfer of temperature, soil temperature is known as radiation. So soil temperature is essential for germination and growth of root and activity of microbes. So and different soil nutrient transformation process, soil temperature is essential. So for apple, germination is the soil temperature should be 18 degree Celsius, maize 25 degrees Celsius, potato 16 to 21 degrees Celsius. The volumetric heat capacity, that is the unit is joule per meter cube per Kelvin. Thermal conductivity, unit is watt per meter per Kelvin. Thermal diffusivity, the unit is meter square per second. Sources, how soil temperature happen, how temperature of soil increase and decrease. What is the source? Soil heating by solar radiation, respiration by microbes, decomposition of organic matter. These are the source of soil heat, soil temperature. Then for the factors affecting soil temperature, those are the thermal capacity or heat capacity, heat of vaporization, thermal conductivity of soil, thermal diffusivity, biological activity, radiation from soil, soil color, soil structure, texture, soil moisture, soluble salts. All these are affecting soil temperature. Then soil air. What is the composition of soil air? Composition of soil air, like nitrogen 79.2%, oxygen 20.6%, carbon dioxide 0.3%. This is the composition of this is the composition of soil air, right? If we see atmospheric carbon dioxide constituent, that is 1/10, right? 1/10 of the soil carbon dioxide composition, that is 0.03%. Here in soil, that is 0.3%, right? And oxygen and nitrogen almost similar to that of atmosphere. And this composition, it depends on factors like nature and condition of the soil, types of crop, microbial activity, seasonal variation. If temperature is higher, then more carbon dioxide concentration we can find in soil. If microbial activity is more, then more carbon dioxide will be we can find. Then mechanism of gas exchange in soil. There are different mechanisms like mass flow, diffusion. Diffusion is due to partial pressure. Importance of soil air for plant and root growth, microorganism activity, toxic element degradation, disease, water and nutrient uptake. All these are affected by soil air. Then soil colloid. Soil colloid, we have two different phases, dispersed phase, another is dispersion phase. Colloidal property, if the soil of the particle size is less than 0.001 mm diameter or less than 2 micrometer diameter, then we can find colloidal properties in soil. So soil colloid have higher surface area, and this is around 1000 times higher than sand, the surface area, and 10 meter square per gram, the surface area is 10 meter square per gram. External surface area and 800 meter square per gram is internal surface area. The external surface area of soil color is 10 meter square per gram. The internal surface area is 800 meter square per gram. So the surface area is much more higher than sand and silt and other soil particles. So here the reaction is much higher. 1 hectare furrow slice, the surface area is around 7 lakh kilometer square kilometer. Surface charge, ionizable hydrogen ion isomorphous substitution. So how surface charge in soil colloid develop? That is due to maybe pH dependent charge, that is due to ionization of hydrogen ion, and another one is pH independent charge, that is due to isomorphous substitution. pH dependent charge, more ionization in alkaline or basic solution. pH independent charge, that is due to isomorphous substitution, as I mentioned, that is silica Si4+, that is replaced by Al3+, Al3+ replaced by Fe2+ or Mg2+. So there is one positive charge that is remain, right? So this is pH independent charge. Then cation adsorption due to double layer. Then adsorption of water, cohesion, adhesion, swelling and shrinkage, dispersion, flocculation, brown and movement, non-permeability, etc. These are the properties of soil color. Types of soil color. 4 major types of soil colors are found. One is layer silicate clay, aluminum and iron oxide or sesquioxide, allophane, amorphous clays, and humus. So layer silicate clay is most common, is phyllosilicate. Among the layer silicates, most common is phyllosilicate. Then aluminum and iron oxide, they are also known as sesquioxide. And allophanes, this is formed from volcanic ash, that is amorphous clay. Humus, that is the resistance mineral after resistance form of organic matter. So gibbsite, the formula is Al2O3.3H2O. Geotherite, the formula is Fe2O3.3H2O.H2O. Aluminosilicate dominated by aluminum dioctahedral, and magnesium, that is called trioctahedral. So silicate clays, if dominated by aluminum, that is called dioctahedral. If it is dominated by magnesium, then that is called trioctahedral. Genesis of layer silicate due to alteration and recyclation. Alteration is the physical and chemical method of genesis. Then recyclation, this is the decomposition of primary mineral and recrystallization of their product. Then relative stages of weathering. Weathering we have already discussed, that is physical weathering, chemical weathering, and microbial or disintegration or decomposition weathering. So rock plus water, that is forms clay, and carbon dioxide plus H2O, it forms H2CO3, that forms again H plus and HCO3 minus, that makes water slightly acidic. Then feldspar, that combine with water to form kaolinite. Then SiO2, that is dissolved silica. Then intermediate weathering encourages smectite formation. Intense weathering encourages kaolinite, aluminum, iron oxide formation. So in intense weathered area, we can find maximum kaolinite, that is 1:1 type clay mineral. And if the weathering process is intermediate, then we can find maximum smectite form. Removal of potassium, calcium and sodium, magnesium from soil solution, that is silicate clay genesis. Okay. So phyllosilicate, it constitutes of aluminum octahedral and silicon tetrahedral. So you can find here, this is the silicon tetrahedral form and this is the aluminum octahedral form. So 1:1 means one silicate clay is there and one aluminum octahedral clay is there. Then 2:1 means 2 silicate and 1 octahedral rare. 1:1 type, examples are kaolinite, halloysite, nechrite, dikite. These are 1:1 type. Then 2:1 type, these are again classified into expanding, non-expanding. In expanding, we can find smectite, vermiculite. These are expanding clay minerals. Non-expanding clay minerals, non-expanding 2:1 type clay minerals, illite, mica, muscovite, biotite. These are non-expanding 2:1 type clay mineral. Then 2:1 type or 2:2 type, those are chlorite. These are non-expanding. Then sesquioxide clays. Sesquioxide clays, these are aluminum and iron oxide clays like Al2O3, AlOH3, Fe2O3, FeOH3. These are sesquioxide clays. Latin word from sesqui means one or one half, that much more oxygen than iron and aluminum. Occurs where silicate leached out and the soil do not swell. Sesquioxide soils, like laterite soil, these do not swell. Swelling and shrinkage property you cannot find in sesquioxides. And this is geothite Fe2O3 we have already covered. Gypsite Al2O3.3H2O. H plus dependent charge due to low pH, protonation, anion exchange site. 0 point charge, higher pH like deprotonation, cation exchange site. Then carbonation like calcite CaCO3, dolomite CmGCO3 whole 2, and sulfate gypsum CaSO4.2H2 are dominated in arid and semi-arid zone. Then ion exchange. Okay, let's first discuss the properties of different minerals based on structure, substitution, shape, surface area, swelling, external and internal surface, CC, AEC. So if we see structure, the kaolinite is 1:1 type, montmorillonite is 2:1 type, illite is 2:1 type. And substitution, there is no substitution in kaolinite. In montmorillonite we have magnesium and iron substitution. In illite we have aluminum substitution. Shape of mineral, that is in kaolinite we have hexagonal shape. In montmorillonite that is irregular. In illite that is irregular. Surface area 5 to 20 in kaolinite, 700 to 800 meter square per gram in montmorillonite. Illite it is 100 to 120. Swelling, that is low for kaolinite, high for montmorillonite, medium for illite. External and internal surface not available, very high for montmorillonite, medium for illite. CEC for kaolinite it is 3 to 15, for montmorillonite it is 15 to 40, for illite it is 80 to 100. Sorry, for illite it is 15 to 40, this is wrong, and for montmorillonite it is 80 to 100. AEC anion exchange capacity, high for kaolinite, low for montmorillonite, medium for illite. Then ion exchange, that is CEC cation exchange capacity and anion exchange capacity. In temperate area, cation is more than anion. In tropical area, that is dominated in 1:1 type, sesquioxide and anion. Sesquioxide formation is higher. So here it is anion is more, AC is more than CC. Ion exchange phenomena first identified by Henry Stephen Thomson in 1850 in England. So remember this point, Harry Stephen Thomson first identified ion exchange phenomena. The second most important phenomena in nature is ion exchange after photosynthesis. Photosynthesis is the most important phenomena in the earth. Then second most important phenomena is ion exchange. Cation exchange first discovered by Thomas Way in 1850, that is the unit is centimole P plus per kg. Anion exchange, the unit is centimole electron per kg. Exchangeable cations can be easily replaced by other cations are mainly present in soil solution. Cation exchange capacity, that is called CC, that the sum total of exchangeable cation or soil can adsorb. Sum total of exchangeable cation a soil can adsorb, that is known as CC. Amount of cationic species bound at pH 7, that is known as CC. Principles, there is reversibility, charge equivalence, ratio law, anion effect or mass action, cation selectivity or lyotropic series. This is very much important. Aluminum 3 plus greater than Ca2 plus greater than Mg2 plus greater than potassium plus is equal to ammonium plus is greater than sodium. So aluminum 3 plus and calcium, magnesium, these are flocculating ion, and sodium, if it is more in soil, that forms the soil disperse, that break down the soil structure. Then complementary ion effect, a root exude H plus ion to exchange with cation or from soil, right? Then CEC, different minerals have different CEC, different fractions, and those fraction of soil have different CEC. Sand soil have CEC 0.5 centimole per kg. Sandy loam it is 5 to 10, loamy it is 10 to 15, clay loam it is 15 to 30, clay it is 30. Minerals and the CEC, kaolinite it is 7 to 10 centimole P plus per kg, montmorillonite it is 80 to 100, vermiculite it is 100 to 150, illite it is 25 to 30, chlorite it is 25 to 30, iron and aluminum oxide it is 5, humus it is the highest 200 to 400 centimole P plus per kg. What are the factors affecting CEC? If the fineness factor affect the CEC, if the texture is fine, then there is more CEC. Organic matter higher means more CEC. Clay mineral, if we find higher montmorillonite and vermiculite, the CEC will be higher. If it is higher kaolinite and illite, then the CEC will be lower. Soil pH, if it is soil pH is higher, then the CEC will be higher. In humus, most CEC is pH dependent, right? In humus, most CEC is pH dependent. Then replacing power of cation. In case of monovalent and divalent, monovalent, the series is hydrogen greater than cesium, greater than rubidium, greater than potassium, greater than sodium, greater than lithium. In divalent form, that is boron, barium, greater than strontium, greater than calcium, greater than magnesium. Base saturation. What is base saturation? Percentage of cation exchange capacity that is satisfied by base forming cation. What are the percentage of CEC that is fulfilled by basic cation? That is percentage base saturation. Formula is exchangeable bases divided by CEC into 100. That is percentage base saturation. It is useful in determining the quantity of lime requirement, index of soil fertility, degree of saturation of any cation, right? Soil fertility, if it is the base saturation is greater than 80, then that soil is known as fertile soil. Then anion exchange capacity. Positive charge on clay due to OH of hydroxide of iron and aluminum, 1:1 clay on allophens. Low pH means more anion exchange capacity. Soil with kaolinite dominant clay is having more anion exchange capacity than soil having illite and montmorillonite clay. Relative order of AEC: OH minus greater than H2PO4, 2 minus greater than SO4, 2 minus greater than nitrate, greater than chloride. Importance. What is the importance of AEC? Release of fixed phosphorus, availability of nitrate, sulfate, chloride. Sandy soil have less CEC, less fertilizer hold, more losses or leaching loss, right? So then let's see soil organic matter. This is very much important for soil living or soil health point of view. Energy source of soil microorganism. What is source of energy for soil microbes? That is soil organic matter. That's why it is very much essential. If soil organic matter is higher, then more the CEC, more the soil health. What are the factors affecting soil organic matter? Those are climate, natural vegetation, texture, drainage, cropping and tillage, crop rotation, residue, plant nutrient. These are the factors affecting soil organic matter. Composition of organic residue: around 75% moisture, 25% diameter. Again, from this 25% diameter, cellulose constitute 20 to 50%, hemicellulose constitute 10 to 30%, starch, sugar, this constitute 1 to 5%, protein constitute 1 to 15%, lignin constitute 10 to 30%, fat, wax, tannin, this constitute 1 to 10%. Then rapidly decomposed organic matter, what are they? They are sugar, starch, protein. Less rapidly decomposed organic matter, hemicellulose, cellulose. Very slowly decomposing organic matter, these are fat, wax and lignin. Lignin is the most resistive organic form to decompose. Organic matter, again, aerobic condition, anaerobic condition. What are the organic matter? What are the form of output happens? Like in aerobic condition, carbon dioxide, ammonia, nitrate, H2PO4, SO4, H2O, calcium, magnesium, iron, these are found. In anaerobic condition, mostly dominated like methane, lactic acid, propionic acid, butyric acid, amine, residues, ethylene, humic substances, these are mostly found. Then decomposition of soluble substances. In anaerobic decomposition, sugar is decomposed to carbon dioxide and water. In partially oxygenated decomposition, sugar is decomposed to aliphatic acid or hydro alcohols, right? So anaerobic decomposition, glucose is transformed to lactic acid, butyric acid and ethyl alcohol. So what happens? How organic form forms to mineralization happens. So organic matter due to ammonification, it forms organic nitrogen. Then aminization occurs, it forms amide NH2. Then nitrification occurs in two-step process. Nitrification is a two-step process where ammonia NH3 forms nitrite by nitrosomonas, and nitrite forms nitrate NO3 by nitrobacter. This is called nitrification process. What is denitrification? That is nitrate form in presence of Pseudomonas bacillus. It forms nitrogen gases NO, N2, etc. So then decomposition of insoluble substances like protein, aminization, ammonification, nitrification happens. Then cellulose forms cellobiols, then glucose, organic acid, carbon dioxide and water. rapid in well aerated soil, cellulose decomposition rapid in well aerated soil, neutral to alkaline soil. Hemicellulose, it forms sugar plus uronic acid. Uronic acid is pentose plus carbon dioxide. Sugar forms organic acid, alcohol, carbon dioxide, and water. Starch, in presence of amylase, it forms maltose. And decomposition of ether and fat substances like fat, it forms glycerol and fatty acid. Then glycerol forms carbon dioxide and water. Mineralization means organic matter forms transformed into mineral or inorganic matter. That is called mineralization. Immobilization means inorganic form, it is transformed to organic form. That is called immobilization. Factors affecting decomposition. What are the factors affecting decomposition of this organic matter? Those are temperature, soil moisture, nutrients, soil pH, texture, toxic element. So role of organic matter, as you know, this is used as energy for different microbes in soil. Then this helps in maintaining the soil health. This helps in nutrient mobilization, decomposition of different substances in soil. This maintains particularly soil health. Then humus. What is humus? Humus is complex, resistance, brown or dark brown, amorphous and colloidal substance. Formation of humus, that is decomposition and synthesis. So in humus, there is non-humic group and humic group. Non-humic group, like 20 to 30% of organic matter, that is polysaccharide, protein, carbohydrate, wax. These are non-humic group found in organic matter. Humic group, there are humic acid, fulvic acid, lignin, and humin also. So theory of humus formation. What are the theory of humus formation? Like lignin theory proposed by Waxman in 1936. Conovas theory, that is by cellulose decomposing microorganism. Polyphenol theory, that is by Flake and Society. Condensation of phenolic material. Properties of humus. Humus impact black color to soil, and it has CN ratio 10:1, and it is having negatively charged. CEC of humus is 150 to 300 centimole per gram. It increases the aggregate stability of the soil. Clay humus complex, that is calcium as binding agent, iron as binding agent. So carbon cycle, if we see CN ratio detailed lecture you can find in my YouTube channel. So CN ratio is smaller in subsoil, low in arid than humid region. In soil it is quite constant, that is 8 to 12:1. So CN ratio, if it is higher, means there is immobilization happens. If CN ratio is lower, then mineralization happens. So CN ratio of uncultivated soil is 8:1 to 15:1, mostly 10 to 12:1. Legume and FYM, it is 20 to 30:1. Microorganism, it is 4 to 9:1. Straw, it is 100:1. Sawdust, it is 400:1. Then soil biology. This is the living component of soil, right? Soil biology having microbes and functional activity, microbial and functional activity, and energy in soil. Okay. Population of biology, molecular ecology, community ecology, these are the forms of soil biology. Soil organisms are again classified into soil flora and fauna. Soil flora again classified into microflora, microflora. So macroflora are higher plants, microflora are bacteria, actinomycetes, fungi, algae. Then fauna, soil fauna are again classified into microfauna, microfauna are arthro, mole, and microfauna are protozoa, nematode, rotifort. So algae are again BGA, green algae, yellow green algae, diatoms. Then bacteria again heterotrophic, autotrophic bacteria are found. So soil organisms are based on soil temperature, then soil moisture content. Some are aerobic, some are anaerobic, like that.
So students, you have gone through a marathon series on soil science. So let me know how you feel, and if you like the video, then give me a thumbs up so that I would know that these videos are really helpful. And if you have any doubt, you can comment in the comment section, and I'll try to find out a solution. And if you want any other topics or any lecture on other topics, then you can let me know. And if you want to join with us, then you can click on the link that is agriculture Q&A, that is you can find in description, and here on the screen you can also see that link, agriculture Q&A. Go and join there. We are organizing different quizzes on this group, so you can join and enjoy different quizzes. And don't forget to subscribe our channel and press the bell icon so that you can get the updates whenever I put a video in my YouTube channel. So good luck and have a great day.